Today we're going to talk about comparing real numbers and graphing real numbers. Before we get to that, first I want to talk about square roots. So a square root is indicated by this symbol right here. Okay, it kind of looks like a check mark combined with a division sign. And when we have a square root symbol, we're asking ourselves what number times itself gives us the number underneath the square root. Okay, that's also called a radicand, but we'll get to that later in Algebra 1. So a square root basically asks you what number times itself gives us the number underneath it. So for example, if we have the square root of 36, what number times itself would give us 36? The answer is 6. And why is that? Because 6 times 6 times 6 is 36. So the square root of 36 is 6. So a square root, again, asks yourself what number times itself gives us that number underneath the square root. So on this right-handed column, I have some numbers written down, and these numbers are actually called perfect squares. The reason why they're called perfect squares is because they're integers that have a square root that is also an integer. So if you look, the square root of 1 is 1. The square root of 4 is 2, because 2 times 2 is 4. The square root of 9 is 3. So these are your perfect squares, and I can go down the line. Square root of 25 is 5. I skipped a couple here. Square root of 49 is 7. And we could actually keep going with this. Basically, all you do to get these numbers, the numbers that I have on the left-hand side, is you multiply your integers by themselves. And that gives you numbers that are called perfect squares. And we could actually keep going with that. We could write 121, get that by multiplying 11 times 11, or 144, which would be 12 times 12. 111 and 144, or 121, excuse me, and 144, both those numbers are perfect squares. Okay? So anything in the left-hand column here is a perfect square. Now, before we talk about that, so the square root of 9 is 3. That works out really nice. But what if we have the square root of 40? And we're asked what that is. Well, there's two ways we can do it. If we have access to a calculator, we could type it in our calculator and then round it to the nearest 10th or the nearest 100th. But let's say we don't have access to a calculator. Believe it or not, we could still do this one. And I'm going to show you how right now. So on the right-hand side are your perfect squares. Remember, the way I got those is all I had to do was multiply 1 through 10 times themselves, and the answers are our perfect squares. So that means if I take the square root of each of these numbers, they have an integer answer. So let's look at 40. Well, 40 is between these two numbers right here, right? So the square root of 36 is 6, right? Because 6 times 6 is 36. The square root of 49 is 7. So what we can do is we could use our knowledge of these values, called perfect squares, to estimate what the square root of 40 would be. So if you look, 40 is closer to the square root of 36. It's only 4 units away. 40 is only 4 units away from 36, but it's 9 units away from 49. So a good estimate for the square root of 40, you might say something like 6.3. Okay? We wouldn't say 6.5 because it's not really in the middle of 36 and 49. Okay? So for example, if it was the number like 42, right, something like that, that would be right, in the middle almost of 36 and 49. So then we might say 6.5. Now let me just give another example related to that problem. Let's say we have the square root of 47. Well, the square root of 47 is between 6 and 7, right? But see how the square root of 47 is closer to 49? So this answer here is probably going to be about 6.8 or 6.9. Okay? And again, to get the exact answer, you would type it in your calculator. But this gives you a way of also estimating square roots using your knowledge of perfect squares. So here I give you two square roots to evaluate, and I want you to estimate these square roots to the nearest 10th using your knowledge of the perfect squares. Remember, the numbers I just put a box around, those are your perfect squares. Those are numbers that you take the square root of them to give you integers. Okay, so hopefully you tried those on your own. Let's start with the square root of 24. Well, the square root of 16 is 4, and the square root of 25 is 5. So 24 is between 4 and 5, the square root of 24. But it's really, really close to 25. So your good estimate for this would be at 4.8 or 4.9. Okay? And you have to be within 3/10. You don't have to be right on the money because you are estimating. Okay? But if you're within 3/10 of the answer, you'll get full credit for that. And then finally, the square root of 10. So if you look at the square root of 10, it's going to be 3 point something because the square root of 9 is 3, and 10 is a little bit bigger than 9, right? Now, you have to be careful here because between 9 and 16, there's not as many numbers as many of the other numbers, so it's a little bit easier to estimate. So the square root of 16 is 4, right? And the square root of 9 is 3. So we have the square root of 10. There's only 6 integers between 9 and 16, okay? So you might say here like a 3.2 or a 3.3, just because there's not as many numbers in between 9 and 16, okay? But it is closer to the square root of 9, which is 3. So hopefully that helps. So for this problem, we're going to graph these three numbers on a number line. So we have the square root of 12, 11 over 3, and negative 2.2. So we're going to graph these three numbers on our number line. We know they're real numbers because they're going to be able to be graphed on a number line. That was in the last lesson. So the first thing we need to do is, if we don't have a calculator, is estimate the square root of 12. So we have our perfect squares right here, right? We know it's going to be between the square root of 9 and the square root of 16. So it's going to be 3 point something, right? Now, it's kind of on that borderline. Again, just like the last problem, there's not as many values between 9 and 16 for our estimating. So each integer jumps up a little bit in terms of the decimal. So that's 12 is kind of in the middle, right, of 9 and 16, maybe a little bit closer to 9. So you might say like 3.4. That would be a good estimate for the square root of 12. Now again, if you're within 3/10 of the answer for estimating square roots, we'll give you full credit for that. Okay? So now we have 11 over 3. That's a fraction. Well, if you look, we have two decimals now, right? So I want to make this 11 over 3 into a fraction. So you want numbers to be in similar formats when you're comparing them or graphing them. So remember from the last lesson, in order to make a fraction into a decimal, you divide the numerator by the denominator. Okay, so I'm over here. We divide the numerator, which is 11, by the denominator, which is 3. Now, the 11 will make 11.0, just in case we need more numbers for our division. So I bring up my decimal before I do anything, because we didn't move our decimal for our divisor. So 3 does not go into 1, but it does go into 11. And it goes into it 3 times without going over. If I put a 4 there, that'd be 12, that'd be too large. So we subtract and get 2 here. Bring down the 0. 3 goes into 26 times. Subtract, we get 2. Bring down the other 0. And again, it goes in 6 times. So when you're graphing real numbers, I would stop at the hundredths place because you don't need to be super accurate. We're going to take a magnifying glass and zoom in times 100. We need to be relatively close, accurate, but not that close where we're examining, 100 place values in between two integers. So I could say safely that this is about 3.6, okay? Or you could round it up to, actually to be better, to be honest with you, because it's 3.66 repeating, we will round this up to 3.7 because a hundredths place of the 6 will tell us to round that tenths place to a 7. And now we have negative 2.2. So now we can graph everything. So I'll put some integers on my number line. Okay. Now, what happens is we're graphing these numbers, and we have them round to tenths. So what I'm going to do is I'm going to put 9 little marks in between my two numbers because each mark is a tenth. Okay. And now I'll put the value on each mark. I like to put it a little bit above it so you can see it. So we have 3.4, which was originally square root of 12. I like to write the number above the point sometimes to make it clear to the viewer. And then 3.7 would be 3 units to the right of that, which was originally 11 over 3. And then finally, if you remember, we had that negative 2.2, which is between negative 2 and negative 3. So we'll make our 9 marks. The 10th mark is the next integer. And I put it on the second mark. Okay? So there's all 3 of those numbers graphed. Excellent. So the last thing I want to talk about today is increasing and decreasing order. Okay? So if you're asked to list numbers in increasing order, what that means is you're listing numbers from smallest to largest. Okay? As far as the number line is concerned, if you graph the numbers on a number line, you're going from left to right. Okay? And then decreasing order is the exact opposite. That's listing numbers from largest to smallest. And if you're writing those numbers down, you would look on your number line from right to left. Okay? So if we look at the last problem that we did, where we graphed those 3 numbers, here we go. Let's say, so here's the graph. Let's say I needed to write these numbers in increasing order. And let me actually clear this off a little bit just so you can see. Okay? Because we have numbers graphed already. So let's say I wanted to write these numbers in increasing order. Well, we would go from smallest to largest or left to right. So I'd write negative 2.2, the square root of 12, and then 11 over 3. That would be increasing order. Now guess what? If we're doing decreasing order, we would actually reverse that because now we're going this way on our number line in terms of listing numbers. Because this number is the largest, this one's the smallest. So we would do 11 over 3, square root of 12, and negative 2.2 if we are doing decreasing order. Okay, so hopefully that makes sense for increasing and decreasing order. Okay, so copy this problem down in your notes and try it at your seat. So what I want you to do, or in your notes, I want you to graph all these numbers, graph all these numbers. They're not integers. None of them are actually integers. Graph these numbers, and then after you graph them, I want you to write the numbers in decreasing order. So the next 30 seconds are going to be blank, so you could do the problem. But if I were you, I would pause the video. Okay, so there's a couple different ways you could do this. The first thing I want to say is we have 2 fractions, right? It's 3/4 and negative 7/9. Well, let me forget about the negative sign with 7/9 for a second. Do you see on both these fractions how the numerator is smaller than the denominator? Well, guess what that means? If the numerator is smaller than the denominator, that means the fraction is less than 1. So you should know that before you start anything. But for the sake of it, I'm going to make these decimals, and some of you might know where 3/4 lies already. But to make a fraction to a decimal, we divide the numerator by the denominator. Okay? So I'll bring up my decimal. I'm going to go a little fast here because it's the last example. So 4 does not go into 3, but does go into 37 times. Bring down my 0. 4 goes into 25 times. So, and that goes in without any remainder. So 3/4 is 0.75. We already have a negative 1.2. For negative 7 over 9, we're also going to divide 7 by 9. So always divide the numerator by the denominator. Okay? I won't worry about the negative sign until we're done. So I'll bring up my decimal here. 9 goes into 70 7 times, right? With a remainder of 7. Bring down the 0. 9 goes into 70 again 7 times. So that's going to keep repeating. So I'm going to stop right there. But I'm going to round that to the nearest tenth. So this number here, we're going to make that negative 0.7, well, 77 repeating, but I'm going to round to the tenth. So it's going to be negative 0.8. Okay? And then finally, we have the square root of 19. All right? We have to use our knowledge of perfect squares. Let me actually go to a new sheet here. So I just recopied the problem on the next page. But we have to use our knowledge of perfect squares. So I'm going to write the perfect squares down over here. I could stop right now because it looks like square root of 19 is between the square root of 4, which is 16, and the square root of 5, which is 25. And it looks like it's a lot closer to the square root of 16, so my estimate's going to be about 4.3. Okay? That's a pretty good estimate. Some of you might have said 4.2. Some of you might have said 4.4. Okay, as long as you're within 3/10 of the answer, you're in good shape. So now we just graph these numbers. Okay? So put some integers on your number line. And graph everything. So we have 0.75. If you want to, you could round out to 0.8. It's going to be between 0 and 1. So I put it right there on the 8th little mark I made. That's 3/4, right? Negative 1.2 is about right there. I don't have to make 10 marks, so that's pretty close right there. Then we have negative 7/9, which is, we rounded that. It was negative 0.77. We round that to negative 0.8. I'll make my 10 marks. Put it on the 8th one, going to the left. Always write the original number. And then finally we had the square root of 19, which was 4.3. Okay? Now if you remember the question on the last page, the final thing we had to do was decreasing order. So now that we graphed the numbers, decreasing order is very easy. We just look on our number line and write the numbers down from right to left. Because here's the bigger numbers, right? And it gets smaller as we go this way. So I have the square root of 19, 3/4. They're both positive, right? That makes sense. Then negative 7/9, and then negative 1.2. So there would be the values written down in decreasing order. If you were doing increasing order, you would just reverse that. So thank you very much for your attention. The lesson was a little bit longer than I usually like. But I hope if you have any questions about anything, please let me know through email. Have a fantastic day, everybody.